Let's start with some basic definitions to get us started with understanding statistics. So our first key definition is to talk about what is statistics. It's the science of collecting, organizing, summarizing, and then drawing conclusions from data. So what this entails is collecting is mostly about sampling. How do we collect our sample? What tools do we use? What methods do we use? And it's very important how we collect our sample because that reflects how much we can trust this data that we're getting out. Another part is organizing the data. And with organizing the data, we're thinking about the different characteristics of what we collected. So something we'll talk about are the type of variables that we can have come out. Then summarizing the data, this is where we get into the mathematics of it. These are usually calculations or specific values that kind of reflect the data as a whole. And once we get those values out, then we can start making conclusions. We can start summarizing what we found. And something we'll do is maybe talk about what that means for our sample and what that means for our population. So these are the main steps we go through with our data. Data itself is any collection of numbers, characters, images, or just anything that portrays information about what we're collecting. So like for example, let's say we were collecting data about weather, and right now as I'm recording it, it's a beautiful day in Portland. So if I was collecting numerical data, maybe for numbers I would be collecting the temperature outside. So maybe it is 68 degrees Fahrenheit. So I'd be collecting temperatures, and then maybe tomorrow I collect the temperature as well. So I'd have this list of numbers. Another way is to collect words. So maybe I would just take the word sunny, and then maybe tomorrow it's rainy, so I'd write that word down. So we could have this list of words. We could use pictures. So like instead of writing the word sunny, I can draw a picture of a sun, and then when it's rainy, picture of rain, and then anything else that we can use that gives us information. What's important is when we collect this data, so where is it coming from? There's two places that our data is going to come from, either the population or a sample. Now, population data includes all of the data. That means we talk to absolutely everyone, which in terms of like if I'm interested in weather in Portland across the year, this would mean that I collect the information every single day of the year. If I'm interested in the year, I collect information for the whole year. Now, that takes a lot of time, and population data is typically difficult to obtain. To have absolutely everything, especially when we start talking about surveying people, if we're interested in some claims about the United States, that means we'd have to talk to everyone in the United States, which is very difficult to do. So it's difficult to obtain. However, it's very accurate. If we get that information out, that's exactly what we're interested in. So if I did collect the weather in Portland for the whole year, then I have all the information that I need. But it takes a lot of time, but it's very accurate. Something we want to move to is the idea of using samples. And samples can end up kind of describing what's happening with the population so that we can avoid this very difficult to obtain data and should be fairly reflective. So sample data is just coming from a portion of the population. Typically what you do is you choose some sample size, and with that sample size, that's the group that you want to take from the population. So say instead of collecting information on temperature for Portland across the whole year, I said, I'll just collect like 3 days within each month or something like that. It's a little easier. Then I don't have to worry about collecting my data every single day. I just take a random sample across the year. And what should happen is that data should be fairly reflective of if I had this more difficult to obtain data. So this is easier to obtain. However, there is going to be some error involved. It's not going to be a perfect reflection, but depending on how we collect our sample, then it should be pretty close. But there might be error to it. So what we're going to do here is practice this idea of population versus sample, because this is going to be a theme that we talk about pretty much throughout the whole course, because it's very important. Are we talking about a population or are we talking about a sample? So let's say we wanted to draw a picture to represent this idea of sample and population. Well, population is always going to be this big thing. So what I could do is just draw this big rectangle, and that would be our population. And then our sample always has to be a part of the population. So we'd have this group that would be within this rectangle, and it would be a smaller portion of that larger rectangle, and that would be our sample. So if we were interested in this average height of a PCC student, if we were collecting this information from a population, this would be where we would collect the heights of all PCC students and then take their average. If we were taking a sample, then what we could do is choose some sample size to use. So let's say we wanted to talk to 100 students. What we could do is collect the heights of 100 random PCC students. So this is where we can see the difference. If you imagine I said, okay, your project for this term is to go out and collect the heights of every single PCC student. That would probably take a lot longer than just the term that we have together, because PCC students aren't even just in Portland, they're everywhere. So with that, especially with this online class, we have students coming from all across the United States, even abroad. So this would be very, very difficult to do. Whereas if I said, collect the heights of 100 random PCC students, that's a little more easy. You might be able to do that just through email. So that gets at kind of the ease of collecting a population versus sample data. But let's talk about once we get these numbers out. So let's say I took a sample and I took their average, and I saw from these 100 students, average height is 5'7". Now, a mixture of this being a large sample mixed with this being a random sample, those are two really good factors to have. To have a large sample size and randomness. That means we have a pretty diverse group within this 100, and it's a large group, which means this number coming out should be pretty close to what's happening within the population. So this is where we get into something called inferential statistics, which we talk about down here, which is the idea of generalizing from samples to populations. And what we do in those sections is we start with something called confidence intervals. And this is kind of closer to the end of the term. And then we do something called hypothesis tests. But both of these use just sample data to talk about what's happening in the population. So what we would do, like for an instance of a confidence interval, is we'd say, we found this 5'7" from this group. What would be an estimate for what's happening in the population? And we'd actually get a lower bound and upper bound for this number. And then hypothesis tests are a little different. We'll talk about that later on. But we can use that with just sample data, talk about what's going on there. However, if we had the population data, maybe if we collected it, we'd get a value out of, say, 5'8". If we have this 5'8", that's exact. That's the exact number that we wanted to obtain if we were interested in collecting average height of a PCC student. This would be our average height of a PCC student if we were able to talk to the population. So, and difficult, but accurate. And then with a sample, it's easier to obtain. However, might have a little error to it. Then another type of statistics, which is what we start out with in this term, is descriptive statistics. And this is where we analyze numerical values that describe and summarize data. So some values that we end up talking about, we talk about means, or the idea of an average. We talk about proportions. We'll talk about medians, standard deviations, all sorts of things, which we'll start talking about in these next few modules. But it's a way of just looking at numerical values to describe our data. So this gets us started with a few definitions that get us into statistics.